Here in this project we are going to discuss about two topics. The first one is Karl Pearson's coefficient of correlation and the second one is Spearman's rank correlation. So about the first one, it would be considered as measuring the degree of correlation between any two variables x and y, which is given as right below. R is equal to sigma of dx dy divided by root over of sigma dx square and sigma, which is root over of dy square, and it is written that where dx is equal to x minus x, dy is equal to y square and dy square is equal to y minus y whole square. And right below there is another alternative formula which is r is equal to sigma xy minus sigma x sigma y divided by n, and it is divided by root over of sigma x square minus sigma x whole square divided by n into root over of sigma y square minus sigma y whole square by n. Before we proceed to take up an illustration for measuring the degree of correlation, it is worthwhile to note some of the following important points. Number 1. R is a dimensionless number whose numerical value lies between +1 to -1. The value +1 represents a perfect positive correlation, while the value -1 represents a perfect negative correlation. The value 0 represents lack of correlation. Figure 15.1 shows a number of scatter plots with corresponding values for correlation coefficient. Now the second number point is the coefficient of correlation is a pure number and is independent of the units of measurement of the variables. The third point is the correlation coefficient is independent of any change in the origin and scale of x and y values. Now the question is, a teacher is interested in studying the relationship between the performance in statistics and economics of class of 20 students. For this, he compiles the scores on the subjects of the students in the last semester examination. Some data of this type are presented in the table. Calculate correlation coefficient for the data. A picture is given right below the statement and you can see here. Now the second topic of our project, which is Spearman's rank correlation. Quantitative measurement of a phenomenon under study is not possible. Sometimes we are required to examine the extent of association between two ordinally scaled variables such as two rank orderings. For example, we can study intelligence, efficiency, performance, competitive events, attitudinal surveys, etc. In such cases, a measure to ascertain the degree of association between the ranks of two variables x and y is called rank correlation. It was developed by Edward Spearman. Its coefficient r is expressed by the following formula, which is r is equal to 1 minus 6 sigma d square divided by n cube minus n, where n is equal to number of pairs of ranks and sigma d square is equal to squares of difference between the ranks of two variables. Now another question here states that salesmen employed by a company were given 1 month training. At the end of the training, they conducted a test on 10 salesmen on a sample basis. So here is another table which states the rest of the question, and you can see here the solution table, which is the calculation of coefficient of rank correlation. Now using the Spearman's formula, we obtain this one, that sigma d square is equal to 24 and r is equal to 1 minus 6 sigma d square by n cube minus n is equal to 1 minus 6 sigma 24 divided by 10 cube minus 10, which equals to 1 minus 144 by 990, which results in 0.855. We can say that there is a high degree of positive correlation between the training and sales performance of the salesman. Like Karl Pearson's coefficient of correlation, the Spearman's rank correlation has a value +1 for perfect matching of ranks, -1 for perfect mismatching of ranks, and 0 for the lack of relation between the ranks. Sometimes the data relating to qualitative phenomenon may not be available in ranks but only in values. In such a situation, it is necessary to assign the ranks to the values. Ranks may be assigned by taking either from largest to the smallest or vice versa, but the same method must be followed in case of both the variables. Sometimes there is a tie between two or more ranks in the first and or second series. For example, if the values of two items are same and presume that the rank of one item may be fourth rank, then instead of awarding 4th rank to the respective 2 observations, we award 4.5, which is 4 plus 5 divided by 2 for each of the 2 observations. Now we will take up an illustration to understand how to award the ranks when the data is given in values and to calculate the rank correlation. The illustration will also give clarity how to award the ranks when values of items in series are same. So here is another table which states the correlation from the following data related to roll numbers of the students, percentage of marks in statistics, and percentage of marks in accountancy. From here we can see that the above data was given in percentage of marks, not in the ranks. Therefore, for calculation of rank correlation, first we have to assign the ranks to the given values. As we discussed earlier, the ranks may be assigned either from the largest value to smallest value or vice versa. Here we assign the ranks from largest to smallest value, which is normally in practice. Now another table is given here which shows the calculation of rank correlation. It is r is equal to 1 minus 6 sigma d square divided by n cube minus n is equal to 1 minus 103 by 10 cube minus 10 is equal to 1 minus 103 by 990, and it is equal to 1 minus 0.10 is equal to 0.90. Now here is the explanation of assigning ranks. For the values of percentage of marks in statistics for 80, 75, 66, 60, there are only single values. Therefore ranks have been assigned 1, 2, 3, 4. Whereas the next value 55 repeated 2 times in the data, therefore 5 plus 6 ranks divided by 2 is equal to 5.5 rank has been allotted to the value of 55 2 times. Similarly, the value of 45 repeated 3 times in the data. Therefore, the ranks 8 plus 9 plus 10 divided by 3 equal to 9. Accordingly, the rank 9 has been allotted to value of 45. In between value of 55, 45, there is a value of 50, hence rank 7 has been allotted to 50. In the same manner, you may try to observe that the assigning of ranks to the values of percentage of marks in accountancy. Now, another question for practice is that 10 competitors in a musical contest were ranked by 3 judges, A, B and C in the following order. So, using rank correlation method, discuss which pair of judges has the nearest approach to common liking in music.